Ta-da, less blurry. That makes no sense to me, but hey, I'll take it. Okay. So the probability type problems that often trip people up are these word problem things. And we have to use some of the probability rules. Nobody sent me a sheet that had your formulas on it. I assume you got one from Dr. Whitener? Cool. All right. So I'll need your help maybe from time to time to be like, do you got this formula? If not, then it might be a formula you have to memorize. She gives you almost every formula you could possibly need, but sometimes there's formulas that are like handy to know. They're not necessarily ones you need to know because you could get there using one of the other formulas, but there's sometimes ones that are like, oh, but if you knew this formula, sometimes it's a little bit easier. So if I get there and you say it's not on the sheet, I'll say, you might want to know this one too. Okay. Let me grab some different color pens. All right. I'm going to read you some words. A survey shows 56% of all American workers have a retirement plan, and 68% of all American workers have insurance for health plans. I'm going to use R for retirement plans, and I'm going to use I for insurance. Is that okay? The survey also shows that 49% of all American workers have both a retirement plan and insurance. So what they're going to do is they're going to ask us to find some things using the information they gave us. And whenever I go through these types of problems, I like to write down what they gave us first. So one of the first things they gave us is they said 56% of all Americans have a retirement plan. I'm going to use R for that. So if we randomly selected an American adult, we would say that the probability that they have a retirement plan, P of R, is, and then we don't usually put down a percent when we do these. We usually turn it into the decimal equivalent. So instead of me writing 56%, are you cool with me writing 0.56? Means the same thing. Okay, so that's one thing they gave us. They gave us another piece of information about insurance. They said the probability that a randomly selected American is going to have insurance then is 68%. So I'm going to put 0.68 for that. All right, and then they gave us one more piece of information that involves us knowing if I should use the intersect symbol, the upside down U, or the union symbol, the right side up U. It says, the survey also shows that 49% of all American workers have both a retirement plan and insurance. Which way do I want my U going? Yeah, I want the downward facing U. So it's going to be the intersect symbol. So I'm going to write that the probability of R intersect I is equal to 0.49. Perfect. So that's all the information they gave us. Now let's see what the heck they want from us. The first question says, what is the probability the worker has neither a retirement plan nor insurance? So again, it said if a worker is selected at random, so just a randomly selected person, that they have neither a retirement plan nor insurance. That's where we have to do the complement stuff. We can either use the little dash symbol or we can use a little C. I like to use the little C because for me, it's kind of like really obvious I wrote complement when I do a little C. So what I'm going to write is the probability that they don't have a retirement plan. So I'm going to put capital R and I'm going to put a little C to say that's the R complement. They don't have a retirement plan. And they don't have insurance. When it says neither, it means they don't have either one of them. So I'm going to write capital I with the little C after it as well to say they don't have a retirement plan and they also don't have insurance. This is what they want from us. And on your formula sheet, did Dr. Whitener give you anything called De Morgan's laws? Okay. So this is an example of De Morgan's laws. You'll know it's De Morgan's laws when both of the things have a complement on it. Both of those things have a complement on it. And here's how it goes. If I have both of those things with a complement on it with the upside down U, I can rewrite it like this using De Morgan's laws. I'm flipping that U into a union sign, so I flipped it over. And the complement goes on the outside like that. So if you have the intersection of both complements, that's the same thing as taking the union of the things and then taking the complement of that union. That's De Morgan's law. It's on the sheet, so you don't have to memorize it. But it's a thing that if you're like, when am I ever going to use De Morgan's laws? Probably when she's saying both things aren't happening. That's usually a hint we're going with a De Morgan's law. Okay, so now how the heck do I use this rule? Do I have R union I? No, I don't. So this isn't helpful yet. It will be helpful in a second though, because you should have another rule on your sheet. Do you have a rule on your sheet that tells you how to find the union of two things? It should tell you that if those things are not independent, and here's the deal, we don't know yet if they are or aren't. So if you don't know, you're going to assume that they're not. We're going to assume they're dependent. Then you're going to use the rule that says that if I want the probability of the union of R and I, that you're going to take the probability of R, you're going to add the probability of I, and then what am I going to do? Going to subtract the intersection of those things. Okay, if anybody's freaked out by what I just did, this should be a formula on your sheet, but instead of having R's and I's, it probably has A's and B's on it. Sound right? I promise I'm not making this stuff up. There should be a rule somewhere. Why am I doing this part? Well, because I can't tell you how to do this part until we actually have that thing right there. So we're going to calculate that. And then here's what's going to happen. If we want the complement of the union of this thing, we're going to take 1 minus whatever this is. But in order to do that, I got to go figure out what this thing is first. So the good news is the probability of R is a thing we already got. We said it was 0.56. And then it says we're supposed to add the probability of I. We already have that. It's 0.68. And then it says subtract off the intersection of those things. We also got that number at 0.49. Yay. So we had all the numbers that we needed for that one. And if we do that calculation, we're going to get 0.75. Okay, but that's not the answer to the question. I need this part to answer the question. What we actually want is we want the complement of what I just found. So we found the union of R and I, but I want the complement of the union of R and I. The complement is always 1 minus the thing. So I'm going to say 1 minus the probability of R union I, which is 1 minus the number we just got, 0.75. So 1 minus 0.75 is 0.25. And there is our answer. Okay, so let me go back to what the question asked. It said, what is the probability that a worker has neither a retirement plan nor an insurance plan? They're saying 25% of workers don't have either one. Ugh, that's not good. the next thing says, what is the probability that a worker has health insurance given that he has a retirement plan? So that given thing is where we put the straight up and down line. And so what I always do when I'm going to do these ones, I put the probability and then I go ahead and I put down the given bar. And whatever they said given, that thing goes over on the right-hand side. So it said, given that he has a retirement plan. So the retirement plan goes here. When it says given, that thing goes on the other side of the bar. And then it said, what's the probability they have health insurance? I'm going to put the I on this side. There we go. So that's what we're looking for. The probability of I given R. You should also have a formula on your page for conditional probability. Does it look something like this? The probability of the intersection of both of those things in the top divided by the probability of the thing that came after the bar. So yours probably had A given B, and then the B went in the bottom probably for her formula. So whenever you do this, you're going to write both of the things with an intersection there, and then whatever thing came after the bar, that's the thing that goes in the bottom. All right, we're cool as long as we have both of these things already. So we need I intersect R. It looks like I don't have that because I wrote R intersect I. But are you okay? The word, when we use intersect, the word that goes with that is and. And so with an and thing, if I said like, I have chocolate and I have vanilla, that's the same thing as having vanilla and chocolate. It's okay for me to turn them around if it's an and. Is that okay? So even though I have R and I and R is going to be the same thing. So I do have that number. That one's 0.49. And then probability of R, I have that one as well at 0.56. So if we do that calculation, it comes out to be 0.875, which means that if we already know that the person has a retirement plan, then there's an 87.5% chance they also have health insurance. So when they say given, that's we already know the given thing. So we're saying we already know they have a retirement plan. Do they also have health insurance? Yes, there's an 87.5% chance that they have health insurance if I already know they have a retirement plan. All right, these next two things are definition questions, but when she asks you these definition questions, she actually wants you to show her math. So that feels weird because you're like, they're definition questions, but you're supposed to prove the definition with a mathematical formula. So I'm going to show you the formulas. So the next one says, are having insurance and having a retirement plan independent events? And then the last one says, are having insurance and having a retirement plan mutually exclusive? So let's go back to the vocabulary of what independent means. Independent was back when I flipped a coin. And I flip a coin and I get heads, and I flip a coin and I get heads, and I flip a coin and I get heads. And so now you're like, well, it's been heads a whole bunch. The next time, isn't it more likely it's going to be tails? And the answer is no. With independent events, it's the thing that happened last doesn't affect the next thing that happens. It's still equally likely to occur. If you have insurance, is it equally likely, like nothing changes in terms of you having a retirement plan? Well, you might have like a gut thought on this, but you actually don't want to write out in English what your thoughts are. She wants to see mathematically. She wants you to prove one way or another. Okay, so here is the actual like definition of independent events. Okay, so if we're using the A's and B's, the probability of A intersect B, or A and B, needs to be equal to the probability of A times the probability of B. If this is true, then we say, yeah, these events are independent. If it's not true when we do it, we'll say, nope, they're dependent. They're not independent. Okay. So in terms of our letters in this problem, we're not using A's and B's, we're using the I's and R's. So we need to figure out what's the probability of R and I, or you could write I and R. That part doesn't matter. Okay. The probability of R and I, we wrote at the top of our page, is 0.49. So I have that answer already. But now what I need to do is I need to see what's the probability of R times the probability of I. Okay, so the probability of R at the top of our page, we said was 0.56, and the probability of I, we said was 0.68. So I'm going to multiply those two things together. And when I multiply those two things together, I get 0.3808. And I could do some rounding, but it doesn't really matter in this case because I already have figured something out. The intersection of the things is supposed to equal what you get if you just multiply those two things together. When we took the intersection, we got that. When we multiplied them together, we got that. So are they independent or dependent? Dependent. So I'm going to write the word but in between here. The intersection of these things was 0.49, but when I multiplied them together, I got 0.3808. So since they're not equal to each other, so probability of R and I is not equal to the probability of R times the probability of I. So these events are dependent.
So anytime it's asking to figure out if the two things are independent, you'll always use.
You're always using that formula, yep. So even though it's a vocabulary word, she always wants you to mathematically show her. And we have a math. Now, let's just talk about this one though. Mutually exclusive means if one thing happens, the other thing cannot happen. So in this case, if you have a retirement plan, you cannot have health insurance. You already know the answer to this question because it said that 49% of them have health insurance and a retirement plan. So obviously these cannot be mutually exclusive. Like I already know this is a no, but that's not good enough. We got to prove that they're not mutually exclusive using the math. So we're going to use the formula for the definition of mutually exclusive. So mutually exclusive events have this formula. The probability of the union of the things, so A union B, is equal to the probability of A plus the probability of B. So the probability of A union B in our case would be R union I or I union R. It's okay either direction again, because if it's an or, doesn't matter which comes first. So the union of the two things, we calculated back up here in problem or part A, we said the union of these two things was 0.75. So I'm going to write that down, that the probability of I union R is 0.75. We calculated that in part A. And then I'm going to calculate the probability of I plus the probability of R. So probability of I, we said was 0.68. And the probability of R at the top of the page, we said was 0.56. And if I add those together, I get 1.24. Uh-oh. They're supposed to be equal, 0.75, but I got 1.24. So I'm going to put the word but in between again. So the probability of I union R is not equal to the probability of I plus the probability of R. And thus, the events are not mutually exclusive. And like we already knew that using our reasoning, but now you've proven it. Question for you. Has she gone over a thing called Bayes formula or Bayes theorem yet? The thing on the back of the paper is significantly more complicated because it involves that particular rule. So I'm going to skip that for now, and I'm going to go to her practice problem on her practice midterm. Because we just learned everything we need to know to do the question that's on her practice midterm. Okay. I don't have this on the handout. This is just her practice midterm question. Sorry, I didn't print up her practice midterm. But remember, I'm gonna like scan all of this and it's all gonna go into Canvas, so don't freak out. You'll be able to get there. Says an engineering school reports that 55% of its students were male. And they're using the letter M for that. 40% of its students were between the ages of 18 and 20. And so they just decided to use A for age for that part. And that 25% were both male and between the ages of 18 and 20. Yeah. I'm going straight to the one that's related to what we just did, and then I promise I'll go backwards. I'm not going to skip it. I just sort of felt like we were in the groove on the probability. So I'm going to keep us in the groove, but I promise I'll go backwards. Okay. So I'm going to write down what they told us. Again, that's how I always like to start these. They told us that 55% of its students were male. So I'm going to write the probability of M is equal to 0.55. And they didn't leave us a whole lot of room on the paper, so I'm going to put it up here. Probability of M is equal to 0.55. And it also said 40% of its students were between the ages of 18 and 20, and they used A for age. So I'm going to say the probability that they're in that age group is 0.40. And it's okay to write 0.4. I just like to put the 40 so that it feels still like the percentage, 40%. But if you just wrote 0.4, you're still right. Nothing wrong with that. Okay. And now it says 25% were both male and between that age group. So when it's the and, I got to have that intersect symbol. So I'm going to write the probability of M and, so intersect symbol. They're in that age group between 18 and 20 is 0.25. And that's all the info they gave us. So they didn't give us anything else, but I've written down all the givens. Now let's figure out what the heck they want. What is the probability a randomly selected student is male or between the ages of 18 and 20? So when they switch it to an or, they want us to just flip the U over. Probability that they're male or between the ages of 18 and 20 means we want M U A. And just like last time, we're going to use the formula that's on your formula sheet. We're going to find the probability that they're male. We're going to find the probability that they're in that age group. And then what do I got to do? Subtract the intersection of those two things. So we're going to find the probability that they're both male and in that age group and subtract it off. And the good news is we have all three of those numbers already. Those were the three numbers they gave us. So probability that they were male, we said was 0.55. Probability that they're in that age group, we said was 0.40. And the probability that it's both was 0.25. And so if we put those together, we got either one's good, but I'm going to put 0.70 so you can see 70% of the students at this school are either male between the ages of 18 and 20. Okay. Second question. What is the probability of a random student being female who is not between the ages of 18 and 20? Okay. I hate how they wrote this because what this is assuming is that you've got two choices for gender, and we know that's not true, but I'm going to change it. So instead of female, we're going to say not male, right? And how would we do not male? We would say male complement. Okay. So what's the probability of random student being the complement of a male and not between the ages of 18 and 20? So we've got two complements going on again. So this is going to be the probability of male complement, and they're not in that age group, so it's age complement as well. We did one just like this on the last sheet, yay. This is a De Morgan's law because they're both the complements of the thing. So what we're going to do is we're going to flip that symbol over. You're going to put that with a U and an A, and then we're going to put the complement on the outside of the parentheses. That's De Morgan's law. So probability of M union A, complement goes on the outside. To answer that, we would take 1 minus the probability of M union A. Well, that's fortunate because M union A was the thing they asked us to do in part A. So this is not so bad. We just have to do 1 minus the 0.70. They're having way too much fun. I don't have you guys cracking up like that. I'm sorry. Maybe next time I'll be funnier. Cool. All right. So the probability that a randomly selected student is not a male and is not in that age group is 30%. Cool. All right. And her last question on her practice midterm, are they mutually exclusive? So we had two different rules. One of the rules was it independent, and one of them was mutually exclusive. We're using the mutually exclusive rule. So we're going to do the A union B equals probability of A plus the probability of B. So I'll write that out. Mutually exclusive. would mean that the probability of A union B is equal to the probability of A plus the probability of B. In this scenario, we don't have A's and B's, we have M's and A's. So we want the probability of M union A. We calculated that in part A, and we said that was 0.70. And then we're going to calculate the probability of M plus the probability of A. We got both of those numbers at the top here. M is 0.55 and A is 0.40. But when you add those up, you get 0.95, which is not a match. So I'm going to put the word but in between here. Nope. So the probability of M union A is not equal to the probability of M plus the probability of A. So these events are not mutually exclusive. How are you feeling about those ones now? She tends to be pretty consistent with types of problems that she chooses. So if you can do the one we just did and that one there, you're probably in good shape for what she's going to ask on the midterm. I'm going to back up now and do her other practice midterm question, which has a bazillion numbers on it. So we'll have to do lots of counting while we do this one, but we'll survive it. Okay. So she gave us this giant block of numbers, which is hard for you to see if you don't have a copy of her practice midterm right in front of you. So I'll try and zoom in a little here. It says, following are the published weights in pounds of all of the team members of the San Francisco 49ers from a previous year. Fortunately, they're put in order from the lightest 49er to the heaviest 49er, because if they weren't, this would be way more annoying. But if on the midterm they're not in order, you got to put them in order first. That's important. But she already did that for this one. Yay. So our lightest 49er is 174 pounds. Our heaviest 49er is 302 pounds. She didn't ask you this, but what's the range? If I want the range, what would I do? Beautiful. And so the range would be 128 pounds if she had asked it. Okay. Why am I doing things she didn't ask? Because what instructors often do when they give you practice midterms is they kind of run you through some of the things that they ask, but not all of the things that they ask. And so try when you do practice tests in any class to think of all the other things you talked about and what are some other questions they could have asked you, but maybe they didn't. So they could have asked us for the range. They didn't, but we can do it. Not a big deal. What did they ask us? Okay. Describe the variable type and level of measurement. What graphs are appropriate? Okay, so variable type. We're going to go back to our very first day. We talked about qualitative variables and quantitative variables. So let's start there. Is this qualitative or quantitative? These are numbers, so quantitative is perfect. But now we probably need to be more specific. When we were under quantitative, what were my choices? Beautiful. Discrete and continuous. I hate this question for that particular designation for one reason. Usually weights are continuous because it's something we could measure. But the particular weight she gave you of these 49ers make me go, is this a trick question? I don't know what she wants you to write. But because she's letting you write sentences, you can get this right either way. You just have to be careful how you answer it, okay? Weights in general are continuous because you could weigh 174.025 pounds. You could weigh 302.222222222 forever pounds. And so that makes it continuous because it could literally be any weight. So in that sense, if you wrote something like, they're continuous because weights are continuous and they could take on any number in between, you'll be correct. The weights she wrote here, however, are discrete because she didn't give you any number. She only gave you whole numbers there. So these feel like they're discrete. So I don't know if this was meant to be a trick question. Probably not. It was probably meant to be a question where you have to go, well, let's talk about the difference between the discrete and continuous. And as long as you do that, you'll get your points. Okay, so questions on that one? You'd be right if you wrote discrete. If you said, these are discrete because they're only whole numbers here. Or you would be right if you said they're continuous, if you said weights are measurements that are continuous because you could weigh really any number in between and then just choose an example. You could say you could be 174.025 pounds. That would make it continuous. Is that okay? Level of measurement. What does that mean?
There's like the 4 levels of measurement. And
Yeah.
time you go up, you could do like something else with it.
Yeah, and there's only 2 that go with your quantitative ones, and that was ratio and interval. Do you remember how to tell the difference between the 2 of them? Yeah, we have a really meaningful 0 if it's a ratio scale. If you have a 49er who weighs 0 pounds, does that mean he doesn't weigh anything? It's a very meaningful 0 there. If he doesn't weigh anything, 0 pounds makes sense. An example of where the 0 doesn't mean the same thing would be if we were talking about temperatures instead. Because if I say it's 0 degrees outside, do I mean there's no temperature? And the answer is, well, no. 0 is just kind of marking the difference between the temperatures that are above 0 and the temperatures that are below 0. It can still be like -10 degrees. But no 49ers can weigh -10 pounds. That doesn't work. So the 0 here would make this one a ratio scale. Beautiful. Nicely done. Appropriate graphs. Well, I'll give you a little hint. If we slide this down slightly, she asks you for a box plot. So that's probably one of the appropriate graphs because she's asking you for it. So yes, a box plot would be appropriate. Can you think of another graph that would be appropriate? A histogram. Nicely done. So variable type we said was quantitative. And we said we could put either discrete or continuous. She probably wants continuous and probably wants you to say something about how it's a measurement, but you could make an argument for discrete as well. Okay, level of measurement we said was ratio because the 0 is meaningful. And appropriate graphs, we took a context clue and said box plot should be because she's asking us for one, and histogram is also good. Are there others that could probably work? Yeah. Those are like the classic ones for this type of data though, but could you do like a dot plot or something like, yeah, we could do dot plots as well, but a dot plot would mean you literally were putting a dot where each of the weights were along the thing, and you're kind of gonna make it be like a histogram, but it has dots instead. Compute the 5-number summary and determine if there are any outliers. She didn't say what the 5-number summary is. What's she really asking you for? Nicely done. Okay, so she said 5-number summary. She wants the smallest number, the minimum. She wants the biggest number, the maximum. She wants Q1 or the 25th percentile. She wants the median or the 50th percentile. She wants the Q3 or the 75th percentile. And then how do we know if there are any outliers? Yes. Okay. She used crazy words. Solving for fences. And if you don't know what that means, it has nothing to do with bunnies and trying to keep them inside a fence. Fences, we use that interquartile range. Do you remember what the interquartile range is? Beautiful. So you take that 3rd quartile or the 75th percentile and you subtract the 1st quartile or the 25th percentile. That's going to give you the interquartile range. And then we multiply by something. Do you remember what number they use? It's 1.5. And so you take 1.5 times that interquartile range and you add it to the biggest number. And you subtract it from the smallest number. And if the data that you've got all falls within the interquartile range, sorry, not the biggest number, the smallest number. I said that wrong. The Q1 and the Q3 is what we do it. And then you look at your biggest number and your smallest number and see, are they inside those fences? Or are they beyond those fences? And that's what would make them outliers for this one. So we don't have a whole lot of space to do the 5-number summary. I'm going to try and write small and fit as many as I can in there. Okay, minimum 174. Maximum is 302. Okay, we got to calculate the Q1. Okay. To calculate the Q1, we got to find the position of the Q1 first. The position of the Q1, so I'll put POS in front of it. The position of Q1. We get that one by doing the 25 over 100 times the number of numbers they gave us. Did they tell us how many? Nope, they just said all of the weights. Okay, cool. We got to count. I got 53. Did anybody else get 53? Thank goodness. Okay, we got 53 of them. And then what am I supposed to do? Add 1. Yep. All right. So this is going to tell us the position of Q1. It's not going to tell us Q1. It'll tell us where it's located. So 25 over 100 is 1/4 times 54 now. And so 54 divided by 4 is our position 13.5. Because we didn't get a whole number, we're going to look at position 13 and we're going to look at position 14 and we're going to average those together to get our Q1. Okay, so our Q1 is going to equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 205. And 14, I got 206. And we're going to divide that in half, and that's going to give us 205.5 for our Q1. Any questions on how I did that? We're going to do the same thing for the median, the position. you're just going to change it to 50 over 100. We still have 53 plus 1, so it's going to be 1/2 times 54. And so half of our 54 is going to give us 27. Because this one is a whole number, we don't have to do the add two things up and divide by 2. My median or my Q2 is just going to be in the 27th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, I got 241. All right, and then position of my Q3 is 75 over 100. So that'll be 3/4 times 54. So 3 times 54 divided by 4 gives me 40.5. So I got to go to position 40 and position 41 and add them up and then divide by 2. Okay. All right. I got 272 and 273. Which means I'm going to get 272.5 for my Q3. How'd I do? Did you get the same numbers as me? Fingers crossed. Okay. What I didn't fit in there are the outlier parts, so I'm going to have to borrow some more of the space that she's got down here on the sheet in order to do that. In order to do the outlier part, we're going to do our Q3 minus our Q1 to find the interquartile range. So IQR is going to be Q3 minus Q1, which for us is 272.5 minus 205.5. All right, I got 67 for the interquartile range. Okay, we're going to take that, we're going to multiply it by 1.5. So 1.5 times our IQR is 1.5 times 67. And that gives us 100.5. And that's the number that I'm going to subtract from Q1 and that I'm going to add to Q3. So I'm going to take Q1 plus 100.5. We said Q1 was not plus, sorry. Minus, Jen, minus. I'm too excited. All right. So we're taking 205.5 and we're going to subtract 100.5. And we're going to get 105. So if we had a number that was smaller than 105 in our list, we would say it was an outlier. But the smallest number on our list was 174. So at least in that direction, we don't have any outliers. So now we're going to go the other direction. We're going to take the Q3. And we're going to add the 100.5. Our Q3 was 272.5 plus 100.5. And that gives us 373. If we had a number that was bigger than 373 on our list, we would say we had an outlier, but our biggest number is 302. So we don't have any outliers. Is that okay? So no outliers. It took us a whole bunch more space to say no outliers. But that's okay. All right. So now we're down in the section where it says provide a box plot. Describe the distribution and provide one additional interpretation of the graph. In other words, give me 2 bullet points about the plot. Okay. All right. When we do a box plot, I got the box part around the Q1 all the way to the Q3 part. So I'll draw a box like that. And so underneath that first line, that's the Q1. So I'm going to write the 205.5 there. And then underneath the end of the box is the Q3. So that's the 272.5. And then where I put the line is supposed to be where the median is located. And we said our median was 241. So it's not exactly halfway between those, right? Because that would mean that I would need it to be like in the 280s over here. So it's the 241 is like a little more this direction than it is that direction. We'll go, I don't know. It's not too far over, but it's not right in the middle. Now the whisker part, those connect to the smallest number and the biggest number. So our smallest number is 174 and our biggest number is 302. So 205.5 minus 174 means I'm going a distance of 31.5. And my biggest number, 302 minus the 272.5 means I'm going a distance of 29.5. So this whisker is like a tiny bit longer than that whisker, but it's not like crazy. So it's like 30 in each direction, 30-ish in each direction. So I'm just going to go out this way and I'll say this endpoint here is the 174. And I'm going to make it about the same length here. It's just a little tiny bit shorter. And I'll make that number the 302. So you're marking when you make a box plot your 5-number summary. So we put our minimum there, we put our maximum there, you put your Q1, your Q2, and your Q3. It's not perfectly symmetrical, but if I had to describe it, it's pretty symmetrical. So I might use the phrase roughly symmetrical or almost symmetrical. It's not exactly symmetrical. If it was, then this number would need to be like exactly halfway between those numbers. It's not quite halfway. It's a little bit skewed to that direction, but not enough for me to say it's crazy skewed. And same thing with the tails. This one was 30.5 and this one was 29.5. Like they're close. They're not like exactly the same, but they're like not far enough for me to say this thing is skewed to the left or skewed to the right. I wouldn't say that. So I'd say roughly symmetrical. Okay.
Can you exactly determine, like, if does it have to be like significantly farther away from the max for it to be an outlier?
We know exactly if it's an outlier or not based on what we did when we did the interquartile range part. We calculated the interquartile range was 67. We multiplied it by 1.5. That came out to be that 100.5. So when you're looking for outliers, you always subtract it from the Q1 or you add it to the Q3. When we subtracted it from Q1, we got 105 and we come back up here. Our smallest number was not smaller than that, so we don't have an outlier. when we added it to the Q3, we got 373, but our biggest number is not beyond that. So we don't have an outlier on that direction either. Yeah. So you don't actually have to do like a roughly, is there an outlier? You actually have a formula that you're going to use.
And then if you say we did have an outlier, how would we write that on the,
Box plot.
yeah.
So like if you had an like if it was like 100 was one of our numbers, you just go put a little point over here.
That's it? Okay.
Yep. You stick a little dot and that would be an outlier.
For skewness, I would I roughly say that it's not roughly symmetrical anymore, it's just skewed to the left or right, like what is the exact, not exact boundary, but
Like what might it look like?
if it was like 5 off instead of 30 off.
Sadly, in statistics, there is not a marker that tells us that. So what's going to happen is your professor is not going to be evil and they'll give you something that is definitely skewed. Because this one is not definitely skewed, that's why I think she wants you to just say roughly symmetrical, because when I've seen her do things before, she gives you something that's like, your tail is definitely like heck along on this side and not on that side. And so you know, because your box plot looks definitely not like that. So it's a really good question. At what point do we know now it is skewed? There is no like actual set for that. The only thing that we do have set for that is the outlier formula. So we have an outlier formula that literally, if it's not smaller than 105 or bigger than 373, we're not going to call it an outlier, but we actually don't have a rule for like exactly when we determine something's skewed or not skewed. Good question. That's the frustrating part about statistics. Not all of it is perfect or exact. But the good news is in this particular class, because she does have free response type questions, you can talk through stuff. So like if you decided you wanted to say this one was slightly skewed, you wouldn't be wrong. It is slightly skewed. Which way is it slightly skewed? That's a little bit harder because the tail is slightly skewed in a way that's different than where the median is slightly skewed. So you'd have to have like a little conversation about why you were saying it was skewed. But you wouldn't be wrong. You would just have to explain why. In the same way that you wouldn't be wrong if you said the weights were discrete. Because the way she wrote the weights, they are discrete. But usually we say weights are contiguous. So as long as you're having that conversation, you're good. In a lot of the stats classes, everything's multiple choice. So it's right or it's wrong. It's nicer when you actually get to explain. Yeah.
It is wrong.
The fences? I have no idea. Did you have you tried to draw the fences in class?
Those ones like
Dash lines? Like beyond, like over here, like I just put some dash lines over here. Okay, I could do that. Something like at 105. I guess that'd be like way over here. Something like that. And 373 would be like probably where I wrote roughly. I'll put the dash line right before roughly. Sure. But we don't have any outliers, so we're okay. I want to say the odds that you're getting asked to actually graph a thing pretty small. Like in super detail, because grading those take forever and ever and ever. So usually they try and make it so that it's not quite a nightmare to have to grade. Doesn't mean it couldn't happen, but I doubt you're gonna have to like do really nitpicky things because that's hard to give partial credit to. I promise the next part's not so bad. Assume that cute little symbol is a sigma is 37.5. What is that? You're both correct. Standard deviation I heard, and then I heard population. And if we put those together, this is the population standard deviation. Correct. Nicely done. Why do you need to know that? Because sometimes in the problem, she ain't going to use the words population standard deviation, so you need to know what that is. This is the population standard deviation, 37.5. What is the z-score for a member that weighs 270 pounds? So we're still talking about one of the 49ers up here. Okay. Provide the calculations only. What does the z-score represent? What does she mean by provide the calculations only? Because she's not gonna let you have a calculator, she's gonna have you just show what you would do, but not actually. You would just write out what the steps were, okay? And then we'll say what the z-score represents. Okay, so our formula for the z-score, is that on the sheet she gave you? Okay, so you don't have to memorize that. I have it memorized. Z is equal to the x value is the value that they're asking you about, minus the mu is the mean of all the numbers divided by, and that's where that sigma goes that they gave us. Okay. She did not give us the mean. Oh, okay. I'm going to cheat and show you how you would do this in her test. Like, let's pretend she doesn't give you the mean. She actually is not on your test going to ask you to add up all those numbers and divide by 53. She's not going to. That's not how she does these. So here's what she would ask you to do. You would need to know what things you can plug in and what things you can't plug in. The X. What's the X in this problem? Yeah, this is the thing that she's asking you about. She's asking you for this person who weighs 270. So that's the X. The thing we did not get was the mean. So we would just leave the mean in there. But she did give you the standard deviation. She said it was 37.5. And so you would go ahead and put that in there. And you would leave it like this. Because she didn't give you the mean, and on the test, you can't go, that's not a thing she's gonna ask you to do, because she's not giving you a calculator, okay? If she gave you 4 numbers and asked you for the mean, that's not unreasonable. But she gave you 53 numbers and asked you for the mean. She doesn't want the mean. Yeah.
I don't know if I'm wrong, but I feel like I heard her say that we were allowed to use only a simple.
You were allowed to use a simple calculator? Cool. I still don't think she'd ask you to add up 53 numbers, because here's what's gonna happen. Half of you are gonna miss it because you only added 52 numbers accidentally because your eyes got off track in the middle of your test when you were actually thinking important thoughts rather than how to add in 53 numbers. She doesn't want you to add in 53 numbers, I promise. That's not what she's asking you to do. But if it was a thing that had like 4 or 5 numbers, that's totally reasonable for her to ask you to do, but not 53. She's not gonna ask you that, I promise. Okay. So leaving it like this would be fine. Let's, for the sake of like coming up with something, I'm just going to invent a mean for this group. Okay. So you can help me invent a mean. We're looking at these. The smallest one's a 174. The biggest one's a 302. And it looks like there's a whole lot of numbers that are kind of over here. Do you want to say 240? We'll pretend it's 240. So this is totally like a Jen is pretending, but let's pretend. I'm going to put off to the side. We'll pretend that the mean is 240 pounds so that I can show you how to interpret the z-score. Okay. So what we would have done, everything else would have been the same. We would have said that the z is equal to the 270 minus the 240. And we would have divided it by the 3750. Okay. So we have 30 in the top and we're dividing by 3750 in the bottom, and we get 0.8 for our z-score. So what that means is that you've got the average weight of all the football players is this 240 here. And then if you went 1 standard deviation away, that's a z-score of 1. And if you go 1 standard deviation away in the backwards direction, that's a z-score of -1. So if I go 1 standard deviation, that's 37.5. So that would be 277.5. And if I subtracted that, I should be able to do that in my head, but I'm freaking out trying to do math in my head. If I go backwards, that's 202.5. Okay, so this would be one standard deviation in the positive direction, and this would be one standard deviation in the negative direction. If I'm telling you that the z-score is 0.8, it's not quite one standard deviation, but it's close, right? So where would this be? It'd be like right about there. So this person is not quite one standard deviation away from the mean in the positive direction. And if it was a negative 0.8, then you would know it was back here. Why do we care? Because one standard deviation away in the positive or negative direction is where hecka our data is according to the empirical rule. The empirical rule tells us that 68% of our data is there. So if I ask you, is this a very unusual player? Your answer is, I'll ask this differently. If the z-score was 2.8, is this a very unusual player?
Yeah.
Yes. If it's 0.8, this is not a very unusual player. So being a z-score of plus or minus 1, not very unusual. Being a z-score of plus or minus 2, starting to get unusual. Being a z-score of plus or minus 3, hecka unusual. Hecka unusual. So remember, we go back to how we did grades before, and down the middle is supposed to be your C. So if you go one standard deviation away this way, this is your B, and this would be your D. So we're almost to the B grades. We're not that unusual. We're pretty normal. But if we were at 2.8, we'd be way over here. You're at your A+ people. Okay, so when she asks you to interpret the z-score, she's asking you, is it unusual? If it's 0.8, you're going to say not very unusual. It's not quite one standard deviation away in the positive direction. If it's negative, make sure you're saying it's below the mean. This is above the mean. It's in the positive direction. Is that okay? All right. I keep looking at my wrist because I didn't put my watch on today. I have like a few more minutes. If you missed class on Tuesday, we did the first few problems on her practice midterm, so I can review those real fast. They were true false questions at the top, and they said, you can determine the mean from a box plot. And a bunch of people went, and we said, no, because remember we made a box plot. And when we did that line, that wasn't the mean. What was it? We can determine the median from a box plot. So median would be true, but because it says mean, we put false. Okay. For a histogram that is symmetric and bimodal, the mean is equal to the median and the mode. And we said, meh. The reason is it says bimodal. If it said it was unimodal or there's only one mode, then this would be true. The mean would equal the median would equal the mode. But if we have two modes, they can't possibly equal the median and the mean because that would, two modes means it's two different numbers. And how did two different numbers equal one number? That doesn't even, I don't know. It's like a weird riddle. I don't even know how to make that work like just in anything. But I was like, it's two different numbers. How did two different numbers equal one number? They don't. They can't. But you could make this true if we switched it to unimodal. The third one said, selecting every fifth exam from a stack of 100 is an example of stratified sampling. And you guys told me, nope. It's close though. It starts with an S. Systematic sampling would be true, but because they said stratified sampling, we said that was false. We said stratified sampling would have been more like if we had a stack of 100 exams and we divided out the people who were from the College of Engineering and the College of Letters and Science and the College of whatever, and then we took a proportional number of each of them, then that would have been stratified sampling, but this is systematic. And then the very last thing we talked through were some vocabulary problems. She gave us a scenario of 100 stocks on the NASDAQ. And we needed to figure out in this particular problem, what was the population, what was the statistic, what was the parameter, the sample, and the variable based on these things that she was writing about. And it said the average increase for all of the NASDAQ stocks. And we said, because we were talking about all of them, we're talking about the population. And so the average or the mean would then become a parameter because it was for the population. It has to match. Parameter and population go together. They both start with the same letter P. And if it's a sample, then the thing we're talking about is a statistic. And fortunately, they also start with the same letter, so it makes it a little easier to remember. All of the NASDAQ stocks in the whole thing, like if we're just taking all of the NASDAQ stocks, that's the population we're talking about. When they said 9%, they said the average percent increase for the past year was 9%. They said the average, so they were talking about the mean or the percent increase for that. Because it was for just the sample of 100 stocks, this one was a statistic instead of a parameter. So when it's for the sample, it's the statistic. The 100 NASDAQ stocks, that actually was the sample that we took. So that was sample. And then it said the percent increase for just one stock in the survey in this particular problem was our variable. So we went through those ones together last time, but now we've got a nice review of all of it. Okay. You guys are going to be fine. You're going to remember that you get to write some answers for anything that's free response. So if you're not like 100% sure, make sure you're explaining your reasoning so you can get some points. That's always really important. Second thing I want you to keep in mind, people, when they get nervous, often will fixate on one problem and not move fast enough through the exam. So when you get the exam, the first thing I want you to do is flip through the whole thing and find something you feel really confident about doing because it's going to help you calm down. Once you calm down, then your brain is working and you can tackle the harder stuff, but I don't want you to start with something that's harder. If you hit something that you know is going to take you a long time, skip it. Go do the other stuff first, come back to the longer things at the end. Because one of the biggest deals about like taking math or statistics or science classes at UC Davis is often instructors write exams that are too long. And the way that people get like the highest grade in the class is that they don't fixate on any one thing. They keep moving and they get as many points as they can rather than trying to get everything right, like in order. Don't take the test in order. Take the test in an order that allows you to keep moving and to stay calm. So that would be my biggest pieces of advice. Having been a student here at Davis once, that was definitely a thing that I always had to remind myself. Don't fixate, come back to things that you're having trouble with because you don't want to spend up all your time. Okay. All right, I'll be thinking good thoughts for you tomorrow.